Number is 16 TE17 and today is about the lecture number 26 of DSP. The basic agenda of this lecture is to get familiar with the pole zero placement. Pole zero placement on the IR filter. IR filter means that infinite impulse response. As we all know that the numerator indicates zeros whereas the denominator indicates poles. If we want to increase the gain, we have to decrease the poles, and if we increase the zeros, then it helps in blocking the frequencies at that points. Decreases magnitude response zeros. If we have zeros in our system, then they decrease the magnitude response, and if we have poles in the system, then they increases the magnitude response. That's why we use both zeros and poles to get our desired magnitude response. Now I will discuss some filters. Number 1, the second order band pass filter design. The formula for R in this case is 1 minus bandwidth. Bandwidth is in decibels over f of s, which is sampling frequencies, multiplied by pi, and is good for the range, which is 0.9 to 1, and for theta in degrees we will divide the f naught by fs and into the 360 degrees. In this case we have poles at 45 degree. If we have pole at the 45 degree, then we have another pole, means that the conjugate of this pole is at 135 degree, and the response in the magnitude domain we have response like this one, and at this point we have f naught, and for the transfer function we have k into z square minus 1 over z square minus 2rz cos theta plus r square, and here this k is the scaling factor which we use in drawing our graphs. K is equal to 1 minus r into under root 1 minus 2r cos 2 theta plus r square over 2 mod of sin theta, means that it includes both positive and both negative values. The second order which we will design in pole zero placement is second order band stop notch filter design. It is very much similar to the previous one, but there is an addition of zeros. Addition of zeros at the same angles. For example, you guys can see there that we have zeros and poles at the same angles, and then the effect of the poles can be cancelled by the zeros. As a result, there is no effect on the system, but it overall improves the pass band performance. And here the graph is like this one, and here it notches the frequency f naught. It means that it is very much similar to the last one, but it notches frequencies at some points like f naught. And the third filter design is first order low pass filter design. Here there are two cases, case 1 and case 2. Case 1 is f of fc, means that cutoff frequency is less than sampling frequencies over 4, whereas in case number 2 we have f of c greater than fs4. In this case the response is this: the pole is at 0 degree whereas 0 is at 180 degree, and here the pole and 0 are very much close to each other, whereas here the graph in the frequency domain is like this one, and here is the same opposite of the previous one. This is all about the pole zero placement in case of 3 filters: the second order band pass filter, the second order band stop filter, and the first order low pass filter design.